Okay. Okay. High pressure gas nitrogen or compressor system. The supply of nitrogen is generally in the form of high pressure cylinder manifold. See our discussion on the screen above. The primary use of nitrogen is to power surgical pneumatic instrument. So the selection and size of nitrogen manifold should be based on the instrument with the highest pressure requirement at the greatest gas consumption rate. Surgical instruments are used to drill or cut bones and metal. Surgical applications include neurology, where instruments are used to cut the cranium, orthopedic service for bone work and joint replacement, facial reconstruction, and open heart surgery. The tools are operated by a foot pedal. The gas supply to the tool and discharge from the tool are both brought to the floor where the foot pedal is located. A series of instruments is currently available with the highest pressure requirement and the greatest flow rate of all instruments. 200 psi gauge or 1,379 kilopascal at the instrument and a maximum flow rate of 15 cfm to operate effectively. Recent development have resulted in a series of tools that requires only 120 psi gauge or 827.4 kilopascal with a maximum flow rate of 12 ECFM or 5.66 liters per second to achieve the same effectiveness as the older, higher pressure line of tools. So other manufacturers of pneumatically operated instruments commonly use a pressure of 160 psi and a maximum flow rate of 15 cfm. For the foreseeable future, various facilities will use a mixture of instruments. So revision in NFPA 1999 made provision for pressures up to 300 psi gauge or 2064.68.4 kilopascal up from a maximum of 200 psi gauge previously allowed. Care must be taken to ensure that all components of proposed distribution system, including connector, hose, etc., are rated and approved for the higher pressure. So the following should be considered when selecting and sizing nitrogen manifold in determining the number of cylinders required. So table 13, selection for nitrogen cylinder manifold. So the number of operating rooms served by the nitrogen or compressed gas, flow rate, and pressure requirement of utilized instrument. So this is the number of operating room, 5 with nitrogen, 1, 2, 4, 5 to 8, and to 12. So andyan yung mga sizes, duplex manifold size. When silent service provided per operating room for in-service and reserve supply. Vacuum system. Now, for the vacuum system, vacuum is a negative pressure created by the vacuum pumps within the piping system. The evacuation of the air from the piping system allows ambient air to be pulled from station inlet and exhausted to the outside. So, the volume of air in cubic feet per minute (cfm) in the piping is greater than the volume of the ambient air at atmospheric pressure entering the system due to expansion under vacuum. In a vacuum system, ACFM is the air that has been expanded in the vacuum volumetric flow. Values of ACFM are more greater than values of ECFM. To convert ACFM to ACFM at 19 inches of mercury for 82.6 millimeter SG, divide ACFM by 2.73. Now, for the ACFM, for the ratio of ACFM to ACFM at other pressure, refer back to table 14. At altitudes above sea level, all vacuum systems have reduced flow. In these cases, the required sizing will need to be adjusted to compensate. To do this, multiply the demand in ACFM by appropriate multiplier shown in table 15, so altitude. In other words, to size the medical vacuum system correctly in accordance with NFPA 99 recommendation of ACFM at 19 inches mercury. So apply the correction factor listed in table 15 to the pre-calculated demand in ACFM at 19. Example 3. A facility's total demand is 27.5 ECFM to produce 19 inches mercury of vacuum at sea level. So if this facility is located at 5,000 feet above, what is the adjusted ECFM? Multiply 27.5 by 1.2, the correction factor from table 15 to get the total adjusted total requirement of 33.3 ECFM at 5,000 feet above sea level. Be sure to use ACFM to size vacuum pump. The patient vacuum system is intended to be a dry vacuum system. However, occasionally fluids enter the piping system accidentally. This should not affect the operation of vacuum pump, but it will only restrict flow as the pipe's inner wall become coated with dry body fluid, dust, and debris. Some facilities use the vacuum system to remove airborne smoke particles from electrical or latest surgery areas. This is not a recommended application for the vacuum system. The smoke contains particulate, hydrocarbon, and water, which, if captured, will condense in the pipe inner walls, producing a tar-like substance that eventually will restrict flow. And then, ito yung vacuum pump. Sa schematic. The vacuum pump system includes duplex or more vacuum pumps, a receiver tank, and automatic drain controls, exhaust piping, muffler, and valve. System components are connected by piping that allow equipment selection, isolation, and drainage of the receiver. The receiver serves as a reservoir and an interceptor for the fluid that may enter the vacuum system. Fluids must be periodically drained to the sanitary sewer from the receiver. System 6, Figure 6 illustrates the schematic of typical duplex medical surgical vacuum pump system. So, yung master alarm value. Master alarm vacuum system. This, okay, yung main, papunta dito. Ito na pang laboratory naman. So, this is now, ito? Vent discharge. So, ito yung vacuum pump. Okay. Then, i-vacuum mo siya, punta doon, discharge na siya. Okay? So, the vacuum pump system must be selected and specified to provide its estimated peak flow demand and a dependable source of medical vacuum at all required times. Its vacuum pump of a duplex system must be sized for 100% of the estimated peak demand. When a triplex or quadruplex system is specified, each pump shall be sized so if one pump fails, the remaining pumps are capable of maintaining the required vacuum at 100% of the peak calculated demand. So provide adequate alternators, duty sighting controls to ensure even wear in normal usage. Alternator controls incorporate a positive means of automatically activating the additional unit or units should the in-service pump fail to maintain the minimum required vacuum. Ito yung duplex type. So the vacuum pump system includes duplex or more vacuum pump, a receiver tank, and automatic drain. Para naulit lang tayo. Okay, naulit nga. The individual exhaust stack should be straight and as short as possible. The exhaust shall be free of dips and loops that might trap condensate or oil. Where such low points are unavoidable, a drip leg and valve drain shall be installed. The collection of the duplex stack to a single stack is permissible if it is ensured that back pressure will not be a potential problem for the system in the future. The exhaust system should be piped to the outside environment, leaving a Rosnick termination. Okay. and be properly screened to prevent snakes, insects, leaves, and debris from entering. The exhaust vent should be a minimum distance of 25 feet from any door, window, outside air intakes, or other opening in minimum distance of 20 feet, 6 meters above ground. The prevailing wind current and the proximity of the power bands and intake lower are very important factors to be considered when locating the outer vacuum pump exhaust. Table 16 provides minimum pipe size for vacuum exhaust riser. So consult the vacuum pump manufacturer on back pressure, friction loss before finalizing pipe sizes and equipment schedule. Minimum of pipe size for vacuum exhaust. Laboratory should be served by a dedicated vacuum line is separate from the medical vacuum line. Be equipped with a suitable fluid traps and be connected by separate lateral slicers and main receiver. Now, because the vacuum requirements vary considerably in the different sections of the hospital, in both peak demand and frequency of use, the total demand for the entire vacuum system should be calculated by the following. Equation 1, FR times FU times NI is equal to AFP, where FR is the room or the station in the ground. UF simultaneous usage factor, NI number of rooms or station inlet, EFP estimated peak flow CFM. Okay, next. Based anesthetic gas management. Anesthesia is a common to medical care as antiseptic care of one for too long. However, exposure to and control of waste anesthetic gases, YAGG, GD, and vapors stopped during surgical production have put healthcare workers and injury. At any given time, more than 250,000 people who work in hospital operating rooms, dental offices, and veterinary clinic might be exposed unnecessarily to harmful levels of WAGD. The waste anesthetic gases and vapors of concern are nitrous oxide and halogenated vapors such as halotane, influrane, metoxychloride, nitrochloroethylene, and chloroform. Those workers with the potential for exposure to WADG include nurses, physicians, surgeons, obstetricians, the gynecologists, operating room technicians, recovery room personnel, dentists, veterinarians, and their assistants, and other auxiliaries. Hospital emergency room personnel may also be exposed, but not on a regular basis. So the WADG system should consist of a dedicated and ball column inlet pipe to the zone valve and either pipe separately back to the medical vacuum pump or pipe 10 feet downstream of the valve box to connect the medical vacuum pump branch main. So, yan. System control valves. After proper selection of medical gas system source, auditing ko, after the proper selection of the medical gas system, source have been made by the plumbing engineer. The next step in the design must of such a system is the specification and installation of piping and control. This typically include source set of valve, main set of valve, inline set of valve, and zone valve box assemblies. The purpose of including these intermediate valves in the medical gas system is to provide the capability of isolating various portions of the system in total or by area. This is useful in case of emergency and to allow for maintenance without interrupting the entire medical gas system. Often, future remodeling the connection should be considered in the determination of valve placement. All valves in medical gas system must be totally accessible, labeled, and if concealed, identified. So, tingnan nyo na yung figure. This allows area shutdown works and certification to be done by the remainder of the system station service. Based on the latest NFA recommendation, some valves that are accessible to those other than authorized personnel should be installed inside valve boxes that are provided with breakable or removable windows. This valve is to be readily operable from standing position in the corridor and on the same floor it served. A gauge installed downstream of the sun valve is required in patient room. The valves and box assemblies should be of full port ball valves with 90 degrees from the open to the closed position. The size of the valve should be based on the size of the pump. They serve to avoid dosing or tearing the fuel and pipeline. Inline shut of valve, other than those in some of boxes, shall have locking handles to allow them to be locked open and closed. Since lock shut of valve should be located in medical gas system at the following location. A. Source equipment outlet. B. Main supply line entering the building. C. Base of the each medical gas riser adjacent to the riser connection. D. Each pit floor distribution zone serving patient area. E. Each anesthetic location. F. Is critical area, intensive care area, emergency room, and many. So these locations cited above are the minimum recommendations. Local plumbing code and NFPA standard and cited conditions should prevail in the final determination of the valve placement. All piping except control line tubing shall be identified. All service main, bench main, and riser valve shall be tagged and alarm valve schedule shall be provided to facility owner for permanent record. Valve and fitting and other components shall be cleaned floor except for oxygen service. So warning system, meron tayong area alarm. So, area alarm are local alarms usually provided with a self-contained pressure switch and a gauge located in the panel. This area alarm monitors in the line pressure in areas to indicate if the pressure difference or pressure are normally operating condition. So area alarm shall be located in all critical areas. These areas are defined in NFPA as follows: ICU, CU, and geology, and IU labs, and cardiac labs. Delivery rooms, operation room, post anesthesia recovery, and emergency rooms, and similar areas in which patients are intended to be subjected to invasive procedure and connected to line-operated patient care-related electrical appliances. Except where each opening or delivery room is valved, the area alarm signals are from the specific line varying the area, with the individual room set-top valve being only one between the activating switch at the room outlet. Care should be taken by the engineer to locate the area alarm and from convenient view of the nursing personally who normally talk the R cover. In case ayaw nung in case of the stoppage of the engineer to locate the inconvenient view of the stacking personnel who normally talk in the work area. In case of stoppage of the medical or gas any error, to work in the area covered. In the case of a stop any other alarm conditions, the proper personnel must take prompt and precise corrective action. Interface control. Interface ngayon. To advise total building maintenance system of any malfunction in the medical gas system. Most manufacturers usually provide a relay interface so controls that do not system. Most manufacturers usually provide a relay interface control so that AC incompatible signal can be provided by the total building maintenance and control. Vertical gas piping installation. So, medical gas pipe sizing criteria. So, piping naman tayo. Kanina sa storage. Paano yung sa size yung pump? Sabi nga, iba yung maximum, iba yung peak. Pag pinagsama-sama mo lahat siya, so, hindi siya pwedeng mag-total. Ibig sabihin, meron siyang factor. The medical rate, flow rate for medical outlet is generally 1 CFM, although this may vary. A source of 50 PSI, 344.7, and a maximum pressure drop of 5 PSI should be considered safety design value mo. The specific pressure requirement for equipment may dictate the pressure required at a specific point in the system. Refer to Table 18 for outlet and diversity factor. So deflection loss data for medical air pipe system and high pressure compressed air is at Table 2122. So this is the So, medical air. So, ito yung table 18. This is for all medical gas. Andito siya. Ang mga medical gas natin is, except vacuum, oxygen and nitrous oxide, abbreviation is O2 and N2O, high pressure nitrogen, medical compressed air, MA, laboratory vacuum. Okay, kasama pala vacuum dito. Okay. So, meron pa rin surgical air o yung high pressure compressed air. Dito na rin yan. So, meron ibang reference na may mag-iupag sa ibang gases. Okay. So, quantity of outlets, for 1 to 3, ang diversity is 100%. Walang minimum. So, 4 to 12 outlets, mag-multiply ka ng 75% ng ang total mo. Minimum. This is the minimum. 10 to 20, so 50% diversity. So, ang minimum is 4 CFM. This is SCFM. So, standard CFM. High pressure nitrogen. And dito naman, mga factor niya. So, check nyo lang to. So, ayan. Laboratory vacuum, ganun din. Ganun din siyang diversity. So, minimum pipe size, recommended pipe size is for system, minimum system pipe tube size is 1/2. Lahat. Sa vacuum is 3/4. This is medical vacuum. Minimum rises yung pataas is 3/4. Minimum branch is 1/2. Minimum single outlet size is 38, 38, 38, 38. Single outlet size. That is minimum. Okay. So vacuum, the flow rate for vacuum inlet is different than it is for other system because areas vary and demand. Table 18 provide outlet rating data and diversity factor. So consider a source vacuum of 19 inches mercury at the service inlet with a maximum pressure drop of 5 inches of mercury. The friction loss data for vacuum system is given in table 23. So ito yung mga table 21, 22, and 23. So ito pala umpisa. Okay? Sayang lang record. Okay, kailangan diretso na. The flow rate for oxygen outlet is 1 CFM, a source of 55 PSI, and a maximum pressure drop of 5 PSI should be used in the design. Adult and infant ventilator require oxygen volumes that exceed 1 CFM flow rate. The recommended flow rate for adult ventilator is 6.36 CFM with no diversity factor. Infant ventilator requires 1 CFM with no diversity factor. So refer to table 18 for outlet rating and diversity factor. So the friction loss data for oxygen pipe system is given in table 19. So later, the nitrous oxide. The flow rate for nitrous oxide outlet is 1 CFM, a source pressure of 55 PSI, and a maximum pressure drop of 5 PSI should be used in design. Refer to table 18 for outlet rating and diversity factor. Oxygen and nitrous oxide pipe sizes should be selected based on the more stringent of the following. Maximum friction loss of 1 PSI per 100 feet. B. Maximum friction loss of 5 PSI to the farthest outlet. So the friction loss data for nitrous oxide pipe system is given in table 19. Ayan siya. So, ng oxygen. So, dito, makikita mo yung doon sa table. Okay, mamaya. Nitrogen muna. So, the flow of nitrogen outlet is 15 CFM per operating room. So, the source pressure is 200 to 300 PSI. And the maximum pressure drop is 10% of the total system pressure. Specific pressure requirement for tools may dictate the pressure required at a specific point in the system. So, table 18 ulit. Nitrogen pipe size should be selected based on the more stringent of the following requirements. So maximum friction loss of 2 psi per 100 foot. Maximum friction loss not to exceed 10% of the total pressure to the farthest outlet. So example to, yung 5 psi, dinivide mo ng total length, ang lumabas is 1.5 psi. So disregard mo na yon kasi mas stringent itong A. So dito ka na ng maximum na 1 psi. Pero pag 5 divided by yung length mo is naging 0.5. So dito ka magbe-base sa 0.5 psi. 5 divided by 100, ba 100 feet yung maximum outlet mo, nagkuha mo is 0.5. So i-design mo sa 0.5. Okay? Pero pag dinivide mo bawat 20 feet, 10 feet lang, so lumabas sa'yo is 5 feet, 5 psi pero 100 feet. So, ang gagamitin mo is yung A, 1 psi. Okay? So, ito, naulit. So, ito yung mga table 19. Data for sizing oxygen in nitrous oxide supply. So, dito yung mga pipe mo, this is the nominal pipe size. Hindi outside. 1/2, 3/4, 1/1/4, 1/1/2, 2, 2.5, 3, 4. So this is now ACFM. This is the pressure drop. Okay? So since dito sa oxygen, hindi ka pwedeng lumampas ng 1. So nandito ka lang. Diba? 0.99. Dito naman is 0.45. So pwede ka mag-interpolate. May 1.0 dyan. Okay? So data for sizing nitrogen supply, piping, and then nitrogen, ang require niya is 2. Yan. Maximum of 2. So, 22 high pressure compressed air. Friction loss table. So, ito yun. So, dalawa. So, yung yung surgical air, itong 175 PSI. Okay. On the low side, yung medical air lang, ito. Ay, hindi, dalawa pala ito yung high pressure compressed air. So, ito naman, table 21, pressure loss for medical air only. Medical air is 50 PSI. Okay. Ito, high pressure compressed air, may alternate ito, nitrogen or ito gamitin mo. So, ayan ang mga value. ACFM to, ACFM. Magulo kasi yung mga reference natin. Dapat ina-identify nila. Okay? So, ito naman data for sizing vacuum piping system. Medical gas piping materials. So, pipe and fittings installed in medical gas system shall be thoroughly cleaned for oxygen service with the removal of oil, grease, and other readily oxidizable materials. Such piping system shall be plugged or capped until final assembly to prevent contamination. So piping materials allowed by code, subject to local requirements, shall be hard rolled, seamless medical gas tube, type K or type L, ESTMB 819, cleaned and capped, and shall bear one of the following marks: Oxymed, Acro, ACR, Oxy, or ACR Med. Mains and branches in piping system shall not be less than 0.5 inch in nominal size. For system operated at pressure between 200 and 300 PSI gauge, ESTMB 819 type K copper shall be used kasi malakas na yung pressure. Joints in medical gas tube shall be braced. However, memory metal coupling with temperature and pressure rating not less than those of the brace joint are also acceptable. Unions are not permitted in any medical gas distribution pipeline system. Sort of bracing lang. Hoses and flexible connection. Metallic and non-metallic hoses or flexible connections are to be no longer than required and should not be permanently concealed in walls, floor, ceiling, or partition. Hoses are to have a flame spread rating of 200 inch in accordance with NFA 255 standard method of test of surface burning characteristic of guarding material. Okay. Sample design calculation. So next na.